Okay, so welcome back and Happy New Year. Here we are in the first few days of 2023. And it's going to be a fairly brief video, and I'm going to do a big reveal on some data I've been gathering that I pretty much guarantee you've never seen before. And if you're like me, it's really kind of fascinating. This basically came out of some work I've been doing for many years trying to understand the issue of the planet Earth temperatures. And I'm not going to use the C word because apparently we live in an age where you can't discuss science anymore. So what we did about a year and a half ago in 2021 is I showed you how to write this software application, very simple software application. As you can see, it's got the date and the time, but it also gathers the real-time outside temperature where you're located and also the inside temperature. And the way it grabs the outside temperatures, it goes to a open source weather website that allows you to access its sensors and grab the temperature in you give it the zip code or whatever, and it gives you a temperature. We did this in order to get more information about what the temperatures are. And what I did in this application is every 5 minutes I grab that outside temperature and save it to disk. So what we're going to talk in this video about is the results for the entire year of 2022, grabbing outside temperatures and storing it to disk and looking at the results, 1 year's worth of temperature data gathered every 5 minutes. Really kind of fascinating. The reason why I was working on this was some issues I've had for many, many years trying to understand the topic that is really, really very complicated. I don't think people understand how complicated this issue of planet Earth temperatures is. It's really quite a challenge to understand it. So what I did about 4 years ago is I did some videos here, a series of videos. You can search on them. I'm not going to mention the name, but you can search on it. And it talked about some of the questions I have about the topic and went through in detail about some of the issues I didn't quite understand and it didn't quite make sense to me, and I'm still grappling with those issues. So I encourage you to take a look at those videos where I talk about planet Earth temperatures. And for example, here's something you've probably seen before, the National Oceanic and Atmospheric Administration temperature chart. And one of the first issues I couldn't understand about this is you can see the difference in temperatures is down to an accuracy of 0.1 degrees Fahrenheit. That's always provided me with a challenge trying to understand how that could be that we're measuring with such a great accuracy. The reason why is because if you know anything about sensing devices, such as this, here's a typical weather sensor device that you might see. Typically those have, if you look at the accuracy measurements, if you look at accuracy specifications from a vendor, typically you might see accuracies that through a very narrow range, for example, 68 to 75 degrees might be plus or minus 1 degree. And then for the normal wide range that you might want to use it in, it's like 4 degrees accuracy. So I've always wondered, how can it be that you can measure 0.1 degree on this when the devices only have, maybe 2 or 4 degrees accuracy? So we did a lot of discussion about that, and we looked at some data. Again, I encourage you to look at that. And one other issue we talked about was what's called bias. And bias is basically what you see here. Here is a photograph of an actual temperature weather measurement location used in one of the weather websites. And you can see the temperature sensor up here. And if you know anything about temperature measurement, you know that this is not really a good thing because you've got a black asphalt parking lot right below this thing and you've got a brick building. And these are emitting heat, which means that if this is supposed to be measuring temperature, you're going to have the sun heating up this asphalt and it's going to bias the reading. This is going to read high whenever there's a lot of heat coming off of this. So I've always been curious about how we can measure with such accuracy when we probably have some sensors that are something like this would have some bias, and there's no real discussion of those issues. So that was one of the reasons behind my attempt to measure actual data. what I want to do is show you the results of the temperature measurements at one location here in the eastern United States over a period of 1 year. And here is the data. And you can see I'm in Excel, and I've got 102,000 readings, and this is every 5 minutes for an entire year. I've got January, February, March, April, and I've also done some calculations. One of the nice things about Excel is you can automatically very quickly calculate average. So I just use an average of this column A, and the average temperature is 47.37 degrees. The minimum is minus 6.6. The maximum is 91 degrees. So really fascinating, and you've probably never seen this before. If you go to the weather websites, they're all about predicting, which they really don't do a very good job of. But here is the actual measured temperature from January to December 2022. So now you might think that now that we've got an average in one particular location in the United States over an entire year, every 5 minutes, that should be a really good number, right? Well, as we said before, we don't know if that could be within an accuracy of 4 degrees. So it might be 45 degrees average rather than 47. So we really don't know. Now, you might also think that what I could do is, this is for 2022, what I could do is, in this coming year, in 2023, do the same thing. And the next year, the average should be higher, right? If we are having a warming, then this should be higher than 47.37. Well, not so fast. And this is one of the other frustrations I have about this. It's really almost impossible for an individual to get the actual data and understand it. And the reason is because you can see here with this departure of temperature from an average, they picked an average sometime here in the 60s, I believe. This departure varies a lot. It bounces all around. So 1 year, like here in 1986 or so, it's high, the average, and here it drops. And then it comes back up and it goes high again. So you really need to get a trend over 10, 20, or 40 years to really get a good indication of an increase. So again, that's one of the other frustrations about this whole topic. Trying to get actual data is really a bit of a challenge. But for those of you who find this interesting, I encourage you to look at my series where we talk about these questions. And if you have any answers to those questions, I encourage you leave them in the comments for those videos. I really appreciate it. If you like any of these videos, I encourage you to hit the like button, subscribe, hit the bell notifications, but most of all, please let others know that we're here so we get some views. Really appreciate it. Otherwise, take care. Have a really good day. Thanks.